Good day everyone. So we're going to go over section 2.5 part 2. And so what we're going to do is we're going to describe the variability or the spread of the data. And so there's got to be another way other than just looking at your measures of center with regards to a data set. Okay, we got to look at also the spread of the data. How spread out is it, or is it very condensed? Is it really spread out, really condensed? Okay. And so there's different measures of variability. One, we have the range. Two, we have what's called the interquartile range, or the IQR. Three, we have the variance. Four, we have the standard deviation. Okay. So just as a reminder, the data set on the right is more condensed than the data set on the left. That's what we're talking about, spread of the data. Is it really spread out, or is it really condensed? Okay. Now, what we're going to find out with the rest of this lecture for 2.5 is that once we talk about the range, before we talk about the IQR, we're going to have to throw in there quartiles and percentiles. Basically, you need to understand quartiles in order to do the interquartile range. And then the author said, well, if we're going to talk about quartiles here, I guess we're going to have to talk about percentiles. So we have a little bit of an interruption here. So it's going to be the range, then we're going to talk about quartiles and percentiles, then we're going to talk about the IQR, and then, if you recall, we have box plots. And so I told you that we're going to hold off on talking about box plots for a little bit until we talk about some other things. And once we're done with the IQR, we can talk about box plots. And so the box plots comes into play. And actually, that's going to be the end of section 2.5. The variance and standard deviation, they're so special, okay, that the authors decided to put it in its own section, and that would be section 2.7. Okay, and so that's what's going to come about today with this lecture. All right, so we have two data sets, data set A, data set B. We'll say the units for both are in inches. So which data set is more spread out? What do you guys think? Take a look. Which one is more spread out, A or B? Well, here's a dot plot for both, and so it looks like clearly data set B should have higher measures of variability than data set A. It's a little bit more spread out, right? So we're going to see that as we calculate the range, the standard deviation, the variance, the IQR, so on and so forth. Okay. All right. So let's talk about the range. Now, there is some worth in saying that our data set goes from 1 to 13 or 1 to 25. Okay. But that's not the range in statistics. Statistics is an actual calculation. So the range is the maximum value minus the minimum value. Okay, maximum minus the minimum. So it's just telling us how spread out is it between those 2 points. How many units are between those two values? Okay. So the range for data set A, maximum is 13, minimum is 1, so that would be 12. The range for data set B would be what? 25 minus 1, or 24. So, easy enough to calculate, right? However, do you see any kind of problems we might run into with regards to the range? Well, I see a couple. One is that we're only looking at two values, aren't we? We're only looking at two observations, and we're ignoring all the other ones. Okay? That's a bit of a problem. And then two, looking at those two observations, we have the potential of having what? Outliers sitting at those values. So now not only are we just looking at two observations, those observations could be outliers. Okay? And so the range is not very reliable because it is not resistant to outliers at all. It only looks at two of the values. Okay? So there's got to be something more than the range. Okay? Okay. We have quartiles. Quartiles, remember I told you we were going to talk about quartiles before we talk about the IQR. So the quartiles, they divide a ranked or ordered data set into 4 equal parts based upon number of observations. Quarter, right? 4. So how many, if you're going to divide a data set into 4 equal parts, how many dividers do you actually need? You don't need 4 dividers. How many do you need? You actually only need 3 dividers. Okay? You need one less divider. Okay? And so the quartiles are Q1, Q2, and Q3. So let's talk about Q1. Q1, about 25% of the data is smaller than it, and about 75% is greater than it. Okay? It has another name. It's also called the lower quartile. And really what it is that it's the median of the lower half of the ranked data. Okay, so if you look at the lower half, okay, you look and you figure out the median for that lower half, you found Q1. Q2, 50% of the data is smaller than it and 50% is greater. Well, we have a name for that one also. You guys already know that name. That's the median. Okay, so Q2 is the median. And then Q3, about 75% of the data is smaller than it and about 25% is greater. Okay, that's also called the upper quartile and is the median of the upper half of the ranked data. Okay, so Q1, Q2, and Q3. Alright, to find the quartiles, you would rank or order the data set, okay, and then you go find the median, Q2. And then Q2 now has separated the entire data set into two parts. Find the median of the data before Q2, you found Q1. Find the median of the data after Q2, you found Q3. Simple enough, okay? So let's go find the quartiles for this data set, okay? Now, that's the raw data, okay? What are we going to have to do? We're going to have to order or rank the data, right? So there's it's ranked, and let's see. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 observations here. So n is odd. So that means the median is going to be the middle observation. That should be easy enough to find. Okay, so we start crossing things out. It looks like 14 would be Q2, the median. Okay, and then we would go ahead and take a look at the data before Q2, the median. That would be from 0 to 10, and we would just find the median of that much smaller data set. Okay, that subset, if you will. We would do exactly the same for the from 20 to 50. That would be Q3. So it looks like the median would be the average of 6 and 8, because we would cross out the 0 and the 10. We would be left with 6 and 8. We would average those two numbers and we get 7. So literally Q1 sits in between 6 and 8. Do exactly the same thing at the with the other data, and so we would average 30 and 35 after crossing out 20 and 50 with one another, and we're left with an average of 32.5. That would be Q3. Okay, so it's the quartiles did their job. Notice that you have two observations, 0 and 6, and then you have 8 and 10. Two more observations. You would skip the median, you have 20 and 30, and then 35 and 50. So notice it separated the data set into 4 equal parts, okay, based upon the number of observations. Alright, let's find the quartiles for this data. We're going to have to rank the data, but this time I believe n is 10. It's even. So that means we're going to have to average the two middle observations for the median. So we would average 20 and 22, okay? Because we would cross out the 3 with the 72 and the 8 with the 50, and then we would find that 20 and 22 are the two middle observations we would average, right? So 21 is the median. So we would have to find the median then from 3 to 20. We're going to leave the 21 out. Don't leave the 20 out. Leave the 21 out. Leave the median out, okay, but not the 20. So we're going to figure out from 3 to 20 what the median is for that, and that would be Q1. So it looks like 14, right? Do exactly the same thing. We're going to leave 22 in there, so from 22 to 72, okay, figure out the median. That would be 37. There's Q3, okay. Did his job again. Meaning the median, the quartiles. So notice you have 3 to 8, and then you skip Q1, 17 to 20, skip Q2, 22 and 26, skip Q3, 50 and 72. So it separated the data set into 4 equal parts. Okay, quartiles. Since we talked about quartiles, the authors decide, hey, let's talk about percentiles now. So percentiles separate a data set into 100 equal parts. All right. Now, in all practicality, this should only be calculated for very large data sets. So you should have hundreds or thousands or even tens of thousands, maybe even millions or even billions of records observations before you go ahead and decide to calculate percentiles. Okay, it really should only be meant for large data sets. We will not be calculating percentiles. It's not worth it. Just allow the computer to do that if you need this. Okay. However, we should be able to interpret them. Okay, because you're going to see these again when we talk about a normal distribution. Okay, so let's make sure that we have a pretty good handle on it. Okay, here's an example. You scored in the 86th percentile ranking for the SAT. Did you do well? How did you fare versus everyone else that took that particular SAT? So, you're going to get a score of 1100 or 1200 or 1300. Well, you can go online and say, okay, what was my percentile versus everybody else? That score itself tells you something, okay, but if you really wanted to get into how you fared versus everyone else, okay, you want to go on the internet and go look it up, okay? So, in my opinion, you did pretty well. You did, and why am I saying that? Well, you scored, if you fell in the 86th percentile, you scored higher than about 86% of all takers of that particular SAT. And about 14% scored higher than you. I say about because ties can throw off that exact percentage. Okay. So, what is the percentile ranking giving you? It gives you the percentage of data that is lower than that particular value. So if you're sitting at the 86th percentile, 86% of the data is before it and about 14% above it. Okay. So graphically, this is what it would look like. So you notice at 1216, okay, we have about 86% of the data before, okay, and then after it we have about 14% of the data. Okay, percentile rankings. All right. So again, we're going to see that later on in the semester. We don't have to calculate percentiles, but understand what it means. Okay, interpret. Okay, we get to go back to the IQR now. So the IQR stands for the interquartile range. Now the reason why we use this acronym is because we like to put this on a computer, but it's really long to put interquartile range on the computer. It takes up too much space, and so we like to use the acronym IQR. So the IQR is the range. Oh, we've heard of that before, the range, maximum minus minimum, right, of the middle 50% of the data. So here's a graph, okay, and I've gone ahead and put Q1, Q2, and Q3 and highlighted the middle 50% of the data, okay, and so that's what we're talking about. So notice that we get to basically ignore that shaded, the unshaded area on the left, and we get to ignore the unshaded area to the right. All we're looking at is basically the middle 50% of the data, okay. Well, it may be obvious what we're trying to do here more on a highly skewed right data set or a highly skewed left data set. So again, we're going to basically ignore the unshaded parts. And so what do we get to ignore then? We get to ignore those pesky outliers. Okay, so the IQR, okay, the IQR is completely resistant to outliers. Okay, the IQR is resistant to outliers. So, what about a formula for the IQR? Well, let's see. It's the range, maximum minus the minimum of the 50% of the data, of the middle, right? Middle 50% of the data. So what's the middle 50% of the data? From Q1 to Q3, what's the maximum? Q3, what's the minimum? Q1. So there's our formula. Q3 minus Q1, maximum minus the minimum. That's all it is. So there's our two data sets again, okay? I think if you took a look at data set A, I think you're going to find that 11 is Q3, and for Q1 it's, let me say that again. For Q3 it's 11, and for Q1 it's 3, okay? And so you subtract those two, you get 8. So we know that the middle 50% of the data spans 8 units. For data set B, I think it would be 19 and 7. So we know that the middle 50% of the data spans what? 12 units. Okay, so notice that that data set B, the IQR is larger than the IQR for A, and we thought that was going to happen. Okay. Now, I've already said this, but I just wanted to make sure it's on the slides, is that the IQR is completely resistant to outliers. So, let's say that the data contains extreme outliers. Which measurements then should we use because they are resistant to outliers? Well, for a measure of center, we would use the median. We've talked about that. And what did we just find out about the IQR? For a measure of variability or spread, we're going to use the IQR. Why? Because they are completely resistant to outliers. Okay, so if you have extreme outliers in your data, probably use those two those measurements. In all other situations, which is most of the time, okay, for all other situations, so the data doesn't contain these crazy extreme outliers, for a measure of center, use the mean, and for a measure of variability, use a standard deviation. Now, we haven't talked about the standard deviation. We're not going to talk about it to 2.7, but I'm sure you've calculated a little bit, okay, in the past, okay, and so now why do we want to use the mean and the standard deviation for all other situations? Well, there's a lot of value in looking at every single value in your data set, okay, there's a lot of worth in doing that, okay, and the mean and the standard deviation both do that, okay, so for most of the time we're going to use the mean and the standard deviation for measures of center and measures of variability, okay, but in those couple of cases where we have these extreme outliers, okay, we might want to switch over to the median and the IQR. Okay, we get to talk about box plots now. So box plot is a plot for quantitative data, and it goes with the following list. So if you remember that our list before, histogram, stem and leaf, dot plot, remember the box plot goes along with this, okay? Now before we draw the box plot, we should talk about what's called the 5-number summary for a data set. And it's real simple. The 5-number summary, all it is that it gives you the minimum, the quartiles, and the maximum. Okay, and if you know those 5 numbers for your data set, actually you know quite a bit about your data. Okay, because you know 25% of the data is between the minimum and Q1, and there's 25% of the data between Q1 and the median, and so on and so forth. Okay, so you sort of know how the data is spread out now, and so on. Okay, and so what does this have to do with the box plot? Well, the box plot is a graphical representation of the 5-number summary. So quickly, the box plot tells you those 5 things. Okay, but besides that, the box plot can also tell you outliers. It can tell you the range. It can tell you the IQR. It can even tell you the shape if you get good at reading the box plots. Okay, so it tells you quite a bit of stuff very quickly. Okay, and so what I have found out is that the best way to get students to understand box plots is to actually give you some data and to draw it. Now, again, am I going to have you draw a box plot on the test? No. But do I expect you to be able to interpret the box plot? Absolutely. Okay, absolutely. So here's our here's our data, and we're going to create a box plot for this data here. So the first thing that we're going to need are the quartiles. Okay, and so sort of trust me on this one. You can go through it. Okay, but I think that the median turns out to be 10, Q1 turns out to be 3, Q3 turns out to be 19. We're also going to need the IQR. The IQR is 19 minus 3, or 16. Okay, so let's say that our variable is the number wrong on an exam that students had. Okay, and so we would go ahead and draw our axis on the bottom. You know, that's where our values of the variable normally goes when we draw these graphs. Okay, and then we're going to draw a line straight up and down at Q1 and at Q3. So we have a line at 3 and a line at 19. They're nice and parallel with one another. The next thing is we're going to draw in Q2 the median, a line straight up and down that's parallel to the other two. And then we're going to connect the tops and the bottoms of each of those lines. There's the box portion of the box plot. Okay, so no matter what box plot you take a look at, Q1, all right, will always be this left line. This right line will always be Q3, and the middle line will always be the median, no matter what. Okay. All right. So the next thing that we have to do is that we have to find what's called the lower and upper fences. Okay, and I'll explain what these are used for. Let's just calculate them really quick, and then I'll explain what they're used for. So the lower fence is Q1 minus 1.5 times the IQR. So I think if you go through that calculation, you get a negative 21. The upper fence turns out to be Q3 plus 1.5 times the IQR. That turns out to be 43. Okay, you might be asking, where did the 1.5 to come from? A professor a long time ago just looked at a bunch of data sets and decided, you know what, if we take these, if we multiply the IQR times 1.5, I think he said, I think for the most part, most people would look at now that these would be outliers if we subtracted that from Q1 and added it to Q3. That's all. Okay, so basically, any values outside the fences are considered outliers. That's what the fences are used for. Okay, so any values outside the fences are considered outliers. So let me draw in the lower fence. The lower fence is way out to the left-hand side. There's the lower fence. There's the upper fence now. The upper fence is at 43. So is there any value that's outside, or values that are outside the fences? And yeah, we have 50, don't we? And so 50 is an outlier. So notice I have a dot way out there at 50. Okay, so a computer is either going to put a dot or a triangle or an asterisk or something like that, some sort of symbol that says, hey, there's an outlier out here. So there might be multiple asterisks or dots or whatever. Well, you may have multiple outliers then. Okay, so here we have some outliers. No, I shouldn't say some outliers. We have one outlier with our data. Okay, one outlier at 50. Sorry, I misspoke. We're almost done with the box plot. The box plot has also been called the box and whisker plot, and the reason why is because there's these lines that come from the edges of the box. Okay, and so we have to draw those now. Okay, and so we're going to start at the left side of the box, right in the middle. We're going to draw a line out to the left. Where do we stop the line? We're going to stop the line at the minimum value that's still inside the fence. The minimum value that's still inside the fence. The opposite way, we're going to start with a line that's on the starting at Q3, going to the right. And where are we going to stop that line? The maximum value that's still inside the fence. So what's the maximum value that's still inside the fence? Hopefully you say, I think that's 35. Okay, so there would be our whiskers then. Okay, so there's our box plot. Okay, notice that we have our minimum of 0 represented by this line right here. We have our maximum of 50 represented by this dot. Now, if there was no outlier out here, this would be the maximum. But since we had an outlier, whatever the maximum outlier would be, that would be the maximum value. If we had an outlier out here, whatever that outlier would be, that would be the minimum. But there's no outlier there, so this line right there would be the minimum. Okay. Q1, Q2, Q3. What would be the IQR? The IQR is the width of this box right here. Okay. The width of the box would be the IQR. So we got 19 and we got 3. So the width of the box is 16. So there's your IQR. We know what the range would be. And this right here, to me, would be a skewed right distribution. It's skewed right. Okay. Why would it be skewed right? Well, because we have it very condensed here at the beginning. 25% of the data, right? It's very condensed right here, and then it gets what? Spread out to the right. So this would be skewed right. Okay. All right. How about this guy right here? What would you say this is? This is looking probably like it's certainly symmetrical, and it's probably what? Bell-shaped, right? Okay. So Q1 is sitting at what? Maybe about 68, and Q2 is the median sitting at 70. Q3 is sitting at about 72. Okay. Oh, I didn't mean to advance it. And so the minimum value would be at about what? 51. Maximum value about 89. Okay, so we know the range, we know the IQR, we know the quartiles, we know we don't have any outliers. And this is probably a nice bell-shaped looking curve. Very symmetrical looking. Okay, what about this guy right here? This guy is probably what, skewed left. Skewed left. Okay, we have a fair amount of data here squished up in the right hand side, and it's being pulled to the left. Being pulled to the left. Okay, so our minimum value, oh dear, this is for GPA. Somebody said that their GPA at this time was 0.1. Holy cow. Maximum value would be 4. Q1 looks like about 2.6, maybe 2.65, somewhere around there. Let's see, Q2 maybe about 3.15, somewhere around there. And then Q3 maybe about 3.5, 3.6, somewhere around there. Okay? And so there's our box plots. All right? So this should end our presentation for part 2 of section 2.5. Thank you for your time.